Okay, so for this last section in here, we're going to talk about even and odd functions. So just like numbers, functions can be even and odd, although some functions are neither. So they're a little bit different that way. But if we look at, so look at this first definition. So if a function f satisfies this equation, so f of negative x equals f of x for every number x in its domain, f is called an even function. For instance, the function f of x equals x squared is even. And the way you prove this is you start with f of negative x, and then you plug in your negative x, and then you simplify, and you see if that equals the original function. So in this case, f of negative x, we're going to plug in negative x for the x. We get negative x squared. Of course, negative x squared is the same as x squared, and x squared is our original function. So we end up with f of negative x equals f of x for any x. The graph of an even function is symmetric about the y-axis. And of course, we know that x squared is symmetric around the y-axis. For the most part, if we have a polynomial and every exponent in the polynomial, well, not even for the most part, this is true. If you have a polynomial and every exponent in the polynomial is even, this is an even function. So if you have, say, x to the fourth minus 2x squared minus 7x to the sixth. So all of these exponents are even. This is an even function. So I don't know what the graph looks like exactly, but I do know that it's symmetric about the y-axis. And it doesn't matter what these coefficients are. So this is an odd coefficient, it doesn't matter. It still is an even function. Just like if we made this 3x squared, well, I mean, this is 1x squared, so 1 is an odd coefficient. So it's still symmetric around the y-axis. Or if it's 3x squared or 5x squared or 8x squared or 10x squared, doesn't matter. It'd still be an even function. And you can test that out by doing this process. An odd function satisfies f of negative x equals negative f of x. So then when you plug in a negative x, it makes the y value negative. Up here with an even function, you plug in a negative x and it doesn't change the y value. So the y value is the same for the negative and the positive. Here we have the negative x makes the y value flip the sign, and maybe negative, maybe positive. But if positive x gives a particular y value, the negative x will give the opposite sign. And that is an odd function. For example, f of x equals x cubed is odd because, and we're going to do the same, we're going to do the same thing if I can figure out what I did here. What did I do? Well, we'll go down here. F of negative x equals, and we're going to plug the negative x into f of x equals x cubed. Now, negative x cubed, the negative 1 cubed is still going to be negative. So this is negative x cubed without the parentheses. So like negative 2 cubed would be negative 8. So negative to the third power is still going to be negative. And then that is, so our original function is x cubed. Now we have negative x cubed, so that is equal to negative f of x. And so the graph of an odd function is symmetric with respect to the origin. Now this is kind of hard to visualize, but it looks like this. Now any odd function has to go through the origin. I don't think that there's an exception to that I've ever seen, and it makes sense to me that that would be the case. At least any continuous odd function. Maybe you could come up with one that's not continuous, but we're not going to worry about that. So the graph of an odd function is symmetric with respect to the origin. And like the even functions, as long as all the exponents in a polynomial are odd, it is going to be an odd function. And it doesn't matter what the coefficients are. So this would be an odd function because all of these exponents are odd. Okay, so last little example here, determine whether the functions are even, odd, or neither. So all you got to do is like we've been doing up here, is see if all the exponents are odd, see if they're all even, or see if there's a mix. So, so this one, we have x to the fifth, we have x to the first, so that's odd, and that's odd, so this is an odd function. That's all, it's simple as that. Now, we could prove this, and if you take a calculus class, we'll get into other types of functions, maybe trig functions where you have to decide, or exponential, well, other types of functions where you have to decide if they're even or odd. And it may not be as simple as just looking at the exponents. With polynomials, it is that simple. But if you want to prove this, let's start with negative x, because both of these rules start with f of negative x, and they see what it equals in the end. So we have negative x to the fifth plus negative x. All we're doing, we're taking this function, plugging in negative x for each x. Negative x to the fifth, that's still going to be negative x to the fifth. This would just be minus x. Now we can factor out a negative. And what is that? That is negative f of x. And so that proves that this one is odd. But again, you don't have to prove it. That will be useful in calculus when you're doing more complex functions. But for now, I think we're only doing polynomials. And so you really just have to look at the exponents. What about this one? So 1. 1 is an odd number, but 1 is an even function. So if you have f of x equals 1, what does that graph look like? That graph is a horizontal line through 1, right? And this horizontal line is symmetric around the y-axis, so that is even. And if you think about it, this is 1, you could rewrite this as 1x to the 0. So 0 is an even number. So any constant is going to be an even function for this reason. It's just a horizontal line, symmetric around the y-axis. And you could also write it as whatever the constant is, x to the 0. X to the fourth, of course, 4 is even, so this is an even function. All right, last one. X to the first power, x to the second power. This one is neither because we have an odd exponent and we have an even exponent. So odd and even is neither. Even and even is odd. Sorry, even and even is even. Odd and odd is odd. So you cannot mix and match. So this one has both, so it's neither. This one just has even, so it's even. This one just has odd, so it's odd. So then it's really as complex as we're going to get now. But if you wanted to learn this part, and that will serve you well when you get to calculus. All right. So if you have any questions about any of that, feel free to email me.